level of efficiency in MATLAB programming. If it is not up to mark, then we'll go to details of MATLAB. So let me start here. We'll start with some linear algebra. Let us say that we are trying to solve a system of linear equations. The linear equations are like this: 5x is equal to 3y minus 2z plus 10, 8y plus 4z is equal to 3x plus 20, 2x plus 4y minus equal to 9. So these are three linear equations. Now you can see there are three variables x, y, z and three different equations. Therefore, we should be able to solve this system of linear equation. Admit. Now, first thing is for solving this linear equation, we have to cast it in the standard matrix form of Ax is equal to b. Now, what is Ax is equal to b? A is the coefficient of the variables, unknown variables x, y, z, and x is a matrix, small x is a matrix, which is the unknown variables, which contains the unknown variables x, y, z. So what we can do is take everything to left side, all these x, y, z components to the left side, and keep the numerical part on the right hand side. So therefore, from the first equation you will get 5x minus 3y plus 2z. Then from the second equation you will get minus 3x plus 8y plus 4z, and from the third equation you will get 2x plus 4y minus 9z. These are on the left hand side. On the right hand side, from the first equation you will get 2, second equation you will get 20, third equation you will get 9. Therefore, the matrix B will be a column matrix, one column which has uh, 3 rows, one column 3 rows. So number of rows for the matrix B is 3, number of columns for the matrix is 1. So you will get automatically B matrix. So that is how you will define B matrix. Then for the matrix A, we will have the coefficients 5 minus 3y, 5 minus 3 plus 2, 8, minus 3, 8 plus 4, 2, 4 and minus 9. So now how to do that? In the first case, let us say A matrix, we are finding out A matrix. For the A matrix, it is a 3 cross 3 matrix because we have 3 rows and 3 columns. In the in the first row, the coefficients are the coefficients of x, y, z. Coefficient of x is 5, coefficient of y is minus 3, coefficient of z is 2. Therefore, that is in one row, so we put them in one row. 5 minus 3, 2. So either you can write 5 space minus 3 space 2, or we can write 5 comma minus 3 comma 2. So that takes care of the first row, which is the first equation. Then for the second equation, it is in the second row, therefore we will give a semicolon. So 5 minus 3, 2, then semicolon, which means we are starting the second row. So that will give us the coefficients are minus 3, 8 and 4. Coefficients of x, y and z are minus 3, 8 and 4. So that constitutes the second row. The columns of the second row are minus 3, 8 and 4. So we write that. Then we'll go to the third column, third row. Therefore we put again a semicolon. So semicolon, then in the third row coefficients are 2, 4, minus 9. Coefficient means coefficients of x, y, z. So coefficients are 2, 4, minus 9. So we write 2, 4, minus 9. Now you have got a 3 cross 3 matrix. So we put all these elements within square brackets. So A is equal to start square bracket 5 minus 3, 2, semicolon minus 3, 8, 4, semicolon 2, 4, minus 9. Then end the square bracket. Now we do not want A to be echoed on our screen, therefore we put a semicolon after the line. When the line ends, when the command ends, we put a semicolon. If we don't put the semicolon, then it will be echoed on our screen. So we have written A. Now for B, as I told you, B is now a 3 row matrix, 3 row, 1 column. So in first row is 10, second row is 20, third row is 9. So we write B is equal to start square bracket 10 semicolon, then go to the second column, second row, which is 20 semicolon, go to the third row, which is 9, end square bracket, suppress the echoing, therefore put semicolon. So now we have defined what is A and B. Then we can find out what is our X. X is equal to A backslash B. This we have discussed earlier what is the meaning of front slash and backslash. As I told you, this equation we have put in the form Ax is equal to B. A is a matrix, B is a matrix, and C is a A is a matrix, X is a matrix, and B is a matrix. Now Ax is equal to B. Now to find out X, what we have to do is multiply inversion of A on both the sides on left side. So A inverse Ax, that is X. So A inverse Ax is equal to A inverse B. So if you have A inverse first then B, then you take left slash or backward slash. If you have B then A inverse, then we take forward slash. So since we have A inverse then B, therefore we are taking the backward slash. So X is equal to A backward slash B. So if we write this, then we will get the values of X, Y and Z. So once you do this, once you have done this, then what you have to do is check whether your answer is correct or not. So that is a safety checking, that you are programming or you are moving in right direction. So always check the solution. Now what should be the check? Check should be C is equal to A star X, which means you are multiplying A with X. When you multiply A with X, you should get B. Therefore, C should be equal to B. So that is how you check. So define C is equal to A star X. Then compare the values of C with B. If they are same, then your program is correct. Okay. Now let us do the same thing using Gaussian elimination method. I hope you know Gaussian elimination method or you have read Gaussian elimination method using numerical methods, numerical techniques. If you have, if you know the Gaussian elimination method, how do you proceed with the Gaussian elimination method? First thing is you augment the matrix A with the matrix B, which means A is a 3 cross 3 matrix. To that you add one more column, which is the matrix B. So you will get a 3 rows but 4 column matrix, which is a 3 cross 4 matrix. So for augmenting we write C is equal to A space B. C is equal to square bracket start A space B. So this is the column augmentation. If you want to augment a row, then that is A semicolon B. So instead of A semicolon B here, since we are doing Gaussian elimination, in the Gaussian elimination, always there is a column augmentation or column concatenation. So to make the column concatenation, you write A space B within square bracket. So that is what we do first. So first is C is equal to A B within square bracket. A with a space B within square bracket. So that is augmenting the matrix. Then you reduce the row. For the Gaussian elimination method, the next thing is reduce the row equivalent form. Reduce it to the row equivalent form. So the augmented matrix is to be reduced to row equivalent form. So what we will do is write CR. R is for row. C remains as the augmented matrix. So CR is equal to RREF. This means row equivalent form of C. RREF is the command in the matrix in the MATLAB, which will make which will give you the row reduced equivalent form of a matrix. So CR is equal to R REF C. So this is the second thing that you will do. Then then you can proceed as usual. Now we have to find out what are the eigenvalues and eigenvectors. Now you know what is eigenvalue and eigenvector. If a if an operator operates on a function and the result is a numerical number multiplied by the function, then we say that the result lambda is the eigenvalue of the function, and v or the function is eigenvector of the function. So for finding out eigenvalues and eigenvector, we must have matrices which are of this form: AV is equal to lambda V, where lambda is the eigenvalue, V is the eigenvector. This you can solve using pen and paper easily. That how to do that? Take the right hand side to the left hand side. V is common, so take V common. Then you will have a minus lambda into V is equal to 0. That will be V is not 0, therefore determinant of a minus lambda is equal to 0. So if you know a, then find out what is determinant of a minus lambda. Solve for lambda, you will find the values of lambda. Eigenvalues you can easily found using the solution. Then you can solve for the linear equations. Now in the MATLAB, how you will do this is very simple. V comma D is equal to eigenvalues of A. So if you know what is and the function or which is the operator, which is the operating matrix, A is the operating matrix, find its eigenvalues EIZ A, that can be given as V D. So that will give you the eigenvalues will be stored in functions V and D, so variables V and D. So this is what you have to do to find out eigenvalues and eigenvectors. Now LU decomposition, I think you know what is LU decomposition and what is mostly you will do LU decomposition. So left and hard triangular matrix decomposition. So how to do that? LU, so you have to find out the vectors or the variables L and U from the matrix A, which are on its left hand, which are below its left hand diagonal. Then after decomposing, so what you will do is write the command LU. Small lu is the matrix command. So lu that operates on A, or that is a function and the variable is A. So if that operates on A, you will get the LU decomposed values capital L and capital U. So if you do that, then L star U must be equal to A. L is the lower triangular matrix, U is the upper triangular matrix. So you have got all of both the triangular matrix. If you multiply both the triangular matrix, that gives you A. That you know. Then QR factorization, where Q is the orthogonal matrix of A and R is the upper triangular matrix of A. If you are going for a QR factorization, then orthogonal matrix into upper triangular matrix, that always gives the matrix. For that, you can find out what is Q, what is R. To find out what is Q and R, I write in this form: Q comma R or Q space R within square bracket, that is equal to QR of A. So that will find out Q and R. Okay. So then matrix factorization. What you call in matrix singular value decomposition, SVD. So if you have SVD of a matrix which gives you the result, you can use the command SVD of A. That will give you three rows, three columns, U, D and V. These are the three variables which will be available as three columns. Now U, D and V, if you multiply them, that will give you A. U and V are orthogonal, D is a diagonal matrix. So this is what is called a singular value decomposition. This you use usually we use this when we have a singularity in the matrix. Uh, Then you can see the help for a sparse matrix. Sparse matrix means most of the elements are zero. There are few elements which are non-zero in the matrix. So when there are most of the elements are zero, there is no point in doing the operation on all the elements because they will give zero. If you multiply or divide, they will give zero or not a number, etc. So there is no point on using those zero values which are high in number, highly dense zero values. You can use the values which are non-zero. So that is what is a sparse matrix. So for that you can see a help on sparse function, SPR FUN. Then we will come to the next phase, which is called curve fitting. Curve fitting means you are given values of x, values of y. You are doing, suppose you are doing an experiment. So in the experiment, you are giving some voltage, you are getting some current. Okay, so as you keep on changing voltage, the current will keep on changing. You do not know what is the relation between voltage and current. You are using some device, unknown device. You want to characterize that device in terms of voltage and current. You apply some voltage, you get some current. You keep on changing the voltage. Current keeps on changing. So what you will do is you record the voltage and corresponding current. So V and I, or you record X and Y. V is X, I is Y. So X is equal to X is known, that you record. Y you have found from experiment, that you record. Then try to find out how you can find out Y from X. Given any X, how you are going to find out Y, or Y as a function of X. So that is what is called a curve fitting. You know what is the nature of the curve. You saw, you plot X and Y versus X. Then you want to find out which function will give you that type of curve. So that is what is curve fitting. You can use a polynomial curve fitting using this command. A is equal to polyfit. Polyfit means polynomial curve fitting x comma y comma n. Then x is tabulated, so x is a matrix which usually should be a row matrix. Y should also be a row matrix. If x is a column matrix, then y has to be a column matrix. So take x comma y, then comma n. N is number of points where you have calculated, or where you have found out x and y. To do this, this function polyfit, that is a function which does a least square fit. Least square fit means least square error. Error will be minimum least. Then why it is a square? When we say LMS, least mean square or least square, etc., that means that suppose and there are two values. One is plus one. Error is in one condition, error is plus one. In other condition, error is minus one. So total error is 0. Plus 1 plus minus 1, which is plus 1 minus 1, which is equal to 0. So that gives you a wrong idea that there is no error. If you add total error, then total error will be 0. Statistically, total error will be 0. That gives you a wrong idea. But if you square them, 1 square is 1, minus 1 square is 1. So square of the error is 2. So therefore, in the least square sense, that is why we take the square. Then take the root over that gives you the root square. Then we find out what is the least square means, which is the curve which gives you the square fitting of the error, which is minimum. Least is minimum, so minimum error. So do that. Do a least square fit with polynomial of degree n. So you are fitting it with a polynomial of degree n. Degree 1 is y is equal to ax is degree 1. Or degree 2 is y is equal to ax plus, sorry, a1x plus a2x square. Degree 5 is a1x plus a2x square up to a5x to the power 5. So degree n means this way you can do a polynomial curve fitting for the data vectors. And its what is the return value? Return value is a vector which is this a1, a2, a3 up to an. So these are the coefficients of this polynomial ax, a1x, a2 x square, a3 x cube, start with a0 of course. So those are the values that you will get as a if you do a polynomial curve fitting. We'll try to see most of these today. Then go to the next value. Now see, write y is equal to poly value a comma x. This will compute the value of the polynomial at value x. So y is equal to a1 x to the power n plus a2 x to the power n minus 1 up to an plus 1. X can be any vector. And so this is, if you know value of a, then you can do this and compare this poly value with your previous one. They should match. This y and the previous y for which you have made the curve fitting, they should match. Let us see one example, which is fitting a straight line. So you try to fit a straight line. Problem is fit the set of data and make a plot of it. Step 1 is find the coefficient of the polynomial. Second, step 2 is evaluate y at a finer scale. Finer scale means you have evaluated y at x is equal to 5 and then next one is x is equal to 7. Finer will be x is equal to 6 or x is equal to 5.2. That is where you want to evaluate it. Then step 3 is plot and see. So this is an example that you have to do. So you are given a set of values of x and y. Then what you will do is polyfit x comma y. Then since it is a straight line, you know straight line is a polynomial of degree n. That's a degree 1. So therefore n will be 1. So polyfit x comma y comma 1. So that will give you the coefficient of the polynomial. Then next is interpolation. Like polynomial, you can do interpolation. This you might have read in numerical methods. So find a curve that passes through all points. Fitting is it may not pass through all points, but it will give you the minimum error. Interpolation it will pass through all points that is given to you, from which you are deriving this. So that will give you ynew is equal to interpolate 1 xy xnew, then the interpolation method. What is the method? Method can be the nearest value, linear interpolation, cubic interpolation, or spline interpolation. So these are the 4 interpolation commonly used interpolation method that you can use. So write the name of the method. X is the set of data, y is the set of data, xnew is the data point where you want to evaluate y, which is not within x and y, which are given earlier. Xnew is a new value of x. Then you are trying to use any one of these methods, nearest method, linear method, cubic method, or spline method. I will tell you that use all these 4 and compare what are the values of ynew, how much changes are there. Then if we are doing a statistical analysis of data, so data analysis and statistics, they require certain MATLAB functions which are common to statistical functions. Like mean, mean gives you the average value. So if you have 5 values, mean is add those 5 divided by 5. So add them, then divided by 5. Median is midway between these 5 values, which will be the third value. STD is standard deviation. So it is from the average value, any other value, if you compare other values, how much they deviate from the standard average value. So standard deviation. Max is the largest value, mean is the smallest value, sum is the sum total of all values, product is the product of multiplication of each value. So these are certain uh, functions available in MATLAB which we can use as per our requirement when we start programming. Then on numerical integration, usually you will use quad, which is adaptive Simpson rule, or quad 8, which is adaptive Newton course rule. Mostly we use quad 8 or quad 45. Nowadays you have got quad 45. You can write use quad, what is your function, how to use it, quad or quad 8, whatever it is. Then give the name of the function that is going to be integrated, then the limits. So that comma, then the lower limit is a, upper limit is b. Then if you want to add any optional thing, then those optionals you can add, those you can see from help. Now let us see how to solve a first order ordinary differential equation. Suppose you are given dx by dt is equal to a function of x and t. X and t are vectors that those are given to you. MATLAB solvers that we use is ODE23, which is second or third Runge-Kutta method. I hope you understand what is Runge-Kutta method. Or you can use ODE45, which is 4 by 3 Runge-Kutta method. Right? So usually we will use ODE45 to solve any first order differential equation. For example, we are given the first order differential equation as dx by dt is equal to x plus t, initial condition which is when t is equal to 0, x0 is equal to 0. So if that is given, try to solve this. Okay. So what we will do is we will first define that function. So function x dot is equal to simp ode tx. So simp ode is the name of the function. Simple ode is a simple ordinary differential equation which has variables t and x, and that gives us returns us x dot. So that is simp ode computes what we are going to compute, x plus t, dx by dt is equal to x plus t. So x dot will be x plus t. So this is how you define the function. First is defining the function. So you define the function. Then t-span. T-span means what is the values spanned by the time t. So t-span is that. We are using that. You can use any other variable. Variable t-span is not mandatory for you. You can write t-length, or you can write t1, t2, or t12, t-lw, lf, anything you can write. So t-span is 0 to 2. This shows that lower limit is 0, integration is on t, so lower limit is 0, upper limit is 2. And then we have x0. x0, the moment you define x0, that will automatically take x0 to be 0. Now you write tx is equal to ODE23. A simple ODE. Simp ODE is the function that is going to be integrated, which we have defined, simp ODE, comma t-span, that gives you the limit. If you have not defined the t-span, there is no point to worry. So simply write simp mode within quote, then comma, then 0, comma 2, then comma x0. x0 is the initial value. We know x0 is equal to 0. So if you have defined x0 is good. If you have not defined x0 earlier, here in this command mode, straight away write x0. In place of x0, write 0. Then write plot tx. This will plot the t versus x. Since solving this equation, you are going to get t and x for different values of t. What are those for different values of t? The values of x that you are going to get within the value 0 to 2 for t. So that will give you the plot. And then xlabel is label of the x-axis. What is the label of x-axis? That is t. Ylabel is what is the label of y-axis? That is x. So if you write that, then below your plot, when the plot is plotted, it will write xlabel. Instead of xlabel, it will write t. in the under the x-axis, and in the side of y-axis it will write x. And then you can have a second order equation. For example, a nonlinear pendulum is a second order equation. D square theta by dt square plus omega square sine theta is equal to 0. To solve this, first thing is to convert this to a ordinary differential equation. Take z1 is equal to theta, z2 is equal to d theta by dt. So then the first one is d square theta by dt square, that you can write as d by dt of d theta by dt. So since we have taken d theta by dt to be z2, so you can say that this is d by dt of z2. Okay, the d square theta by dt square is d of z2 by dt. That is equal to minus omega square sine z1. So that is the second line. And in the first line we have defined dz1 by dt is equal to z2. So now we have got our two first order equations, one second order equation. Let us try to solve it. To solve it, again we have to define first the function. Function z dot is equal to pendulum. For the pendulum, we are writing the function for a pendulum. So p and pen t comma z. Inputs are time, t is equal to time, that gives you the input, and z for z1 and z2. Then outputs are z dot, which is z2 comma minus w square sine z1. Now you can write WSQ is equal to 1.56, that is the value of omega, given value of omega. You can take any given value. We are taking 1.56. You can take 2.89 or 1.32, anything that you want. You can take that value or the value that is given to you. That value we can take as WSQ. Then Z dot is equal to Z2 comma minus WSQ star sine Z1. Okay. So once that is done, then we have to that will solve the equation and give you the result. Now finding zeros of equation. So one function is given to you. You want to find the roots of the function. So how to find the roots of the function? Equate the function to 0. So fx is equal to 0. We have equated the function to 0. Then solve it. Solution of that is x solve is the solution of x for which fx is equal to 0. On the right hand side you write f0 f0 within bracket whatever is your function. You have defined the function. Suppose it is sine x, so f0 sine. Then x0, what is the tolerance? TOL is tolerance. Tolerance we can say e to the power minus 3, which means up to 3 decimal. It is correct up to 3 decimal points. So it is minus 3. Then trace. Trace means it will give you the diagonal values always. So where these are the optional argument. Tolerance and trace are the optional argument. You may not give them these values also. Okay. So you are solving here. Let us take one example. Solve this transcendental equation. Sin x is equal to exponential x minus 5. Find out the values of x for which this is 0. So function will be sin x minus exponential x plus 5 is equal to 0. So fx is equal to sin x minus exponential x plus 5. So define a function for that, then solve that. Okay. Now simple plottings. You can do simple plottings. Plot xy, it will plot xy. Then if you write plot xy comma r, this it will plot xy, but the color of the plot will be black, red. If it is only xy, the color of the plot will usually be blue or black. Now you can write plot xy, then comma colon. You have put colon within quote marks, which means xy will be plotted not as a line but as colon. So at each point of x and y, you will get a colon. So that will give you a plot. And then x2, y2, comma plus. So x2 and y2 will also be plotted on the same plot, but they will be plotted as plot plus. Similarly, you can write a plot xy b minus minus, which means it is black and it is dashed line. So you can see uh, the help or book to find out other functions on plot. Then other plotting commands are xlabel, ylabel we have seen. These are labels on the axis. Title is the title of the text. This comes on the top. Text is the text in the graphics. If you write any text within the graphics, that you can write text, then write within quote whatever you want to do this. My plot, so that will show you my plot. Legend is the legend to the plot. Axis is the limit, axis limit or axis scaling of x and y. GT and gtext is text with local located by mouse. So you locate by mouse a point, there you write whatever is your text you want to write. So these are some commands for plot. Then you can do some specialized 2D plots like semi-log plot. This is a log x versus x. So you can like semi-log x, it is in the x-axis, x-axis is in the logarithmic, y-axis is non-logarithmic, normal. Or semi-log y, y-axis will be logarithmic, x-axis will be normal. Log-log is both the axes are logarithmic. Then you can have a polar plot, or you can have a bar chart, you can have histogram, you can have pie plots. You may not use all these, but you can use maybe the semi-log plots may be useful to you. Then something on your 3D plots. So 3D plot is simply write plot 3, then XYZ, whatever is your style, give that option. For example, T is equal to LIN linear spacing. LIN is linear, spacing means the data is spaced linearly, which means with equal intervals 0, 6 into pi. Pi is predefined in MATLAB. So you can anytime you write pi, it will give you the value of pi. It will write the value of pi. But if you take pi as a variable, suppose you do not know what is pi. Now pi is predefined. So when you are writing the program, you are writing pi is equal to 4.8. So from that point onward, it will always take pi as 4.8. It will not take pi as 22 by 7. Then t is equal to this t. So we have found out what is t. Then x is equal to cos t, y is equal to sin t, z is equal to t. Now you can write plot 3 xyz. That will give you a 3D plot of this. Okay. And then graphics handling, that we will discuss later. Sometimes else when we use it. It is an advanced feature of MATLAB. We are not going to use this right now. Okay. So with this, we come to an end of our discussion for today on MATLAB. I hope you have seen some of these or you have understood some of these. Now, what I will try to do is try to take help of Akhila. Akhila will share his screen and we'll see how to write programs on MATLAB or how the MATLAB commands. Before that, I want to know if you have tried out the programs, earlier programs. If you have tried out, then that will be nice. We'll discuss those things fast. Those will try to work out on a MATLAB program. Once that is over, then we'll try the programs that we just saw or similar programs that we will see. So if you have any comments, please tell me. Give your comments now. रेकॉर्डिंग रेकॉर्डिंग द मन करता है तो रेकॉर्डिंग okay. So are you ready with your programs so that I can ask Akila to share his screen? Akila, please share your screen of MATLAB.
Okay, sir. Sir,
Clear
is
the
it
screen?
visible?
No. So please tell them how you are going to increase the font size. When it is not visible, we can increase the font size so that it will be visible. So tell them how you would
So,
do that.
okay, let's follow my commands. Just open your home tab. Here at the left bottom corner, you will find home button. Here home button, then find the preference. Okay, so look at in the environment section. Here you will get a tab like preference. So when you click the preference, you will get a such like window. Wait, are you getting any changes in the screen? Yeah,
No,
sir, is
that
there
one.
any changes?
No, that window has not come. I think it is
Okay,
not.
wait.
It is slow. Sharing is slow.
Okay, okay, let me check. Sorry. Now I hope everything is fine.
Screen is visible, but it is size is small.
Okay, no problem.
For,
I will show you how you will increase the font.
uh,
So at first you have to click the home button. Here it is home button at the left side corner.
top left corner is
Then
the home button. Then you come to the next one.
preference.
Preference. Go to
Here
preference.
it is the option like preference. So when you click the preference, you will get a window like this.
Yes. Okay. So
Here
look at this window.
at the left side you will get so many options. So you have to find the font. So when you go to the bottom, here you will get a option like font. When you click that, you will get such like a window. Here you can change the font size. So here it is given that how you want your font, whether it is plain, bold, italic, yeah, anything. And at near to that, you will get how much font size you want actually. Here it is already 24. So as it is not clear, so I want to increase the font to suppose 30. So when you put 30, and that just click apply. Here at the bottom you will find apply icon, and then click OK. So let me check again. Sorry.
Okay,
If you
so
want
now it
to
is
increase
visible.
again more,
Further
then you can also go
to
and
32
you
or
can repeat same
36.
thing. Okay, I will do it 40. So then you find the changes. So now it is visible to everyone.
Yes, I think it is visible. Are
So
you
in
able
this
to
way, you
see?
can change the font of the of your MATLAB script.
On the MATLAB screen, you will see that font size has increased, so it will be less strenuous on your eye. So that is what is important. You should not put more strain on your eye or increase the font. Use always really large fonts so that you can see it clearly. So first step is this: when you write, when you are using MATLAB, always ensure that your font size is sufficiently large to be visible. So from that point you will start. Okay. So that is the starting point. Then you, as I told you always in the first class also, then use the command clear. Akila, please write clear.
Okay, okay. So this is the script editor window, and the bottom is
The
what
command
command
window.
window.
In the command window, you
So
can see the
any
command
instant.
prompt. Wait, wait. In the command window, how do you distinguish between command window and script window? In the command window, always you will find the command prompt, which is two greater than signs. So you can see that fx, after fx there is two greater than signs. Those two greater than signs are called the command prompt. So it is prompting you to give a command. That is why it is called a command prompt. So if you find that, and where your it is blinking, your cursor is blinking, then that is the command window. In the command window, you can write CLC, that will clear the command window, or clear, that will clear the previous value, previous variable, clear all, it will clear all variables, clear a particular value name, that will clear the value name. Okay. And now he has given clear all, any all values have been cleared. Now
So
please
sir,
write, right. Okay. Now go to the next line. Okay, go to the
here it
enter
is at the right side. You will find so many values of given
workspace.
variable.
Uh,
Here a variable contain
uh,
this much value. Similarly, answer B, C. These all variable contain some values. So I want to clear this window. So
okay.
to clear this
Wait,
window,
wait,
you just
wait, wait. Akira, wait. Now you see
okay.
that the window Akira just showed you is called the workspace window. It may be on the right hand side, it may be on the left hand side, it may be on the bottom, wherever it is. You can change the position of that window also. It can be right hand side. Take that window, select that window, take it to left side. It will be on the left hand side. So that is what is called the command window. Okay, so wherever you put, that will go there, right?
So just
Ah,
click and drag.
and click and drag and drop. That is what we say. Then you can resize it. Okay, depending on your requirement, you can resize it. Okay, now whatever values are there, we want to clear them. So write clear all. Now if he gives enter, all those values will be cleared. On the workspace, nothing will be there. You can see that workspace is clear. Now Akira, write x is equal to 5.8,
Yes.
x is equal to 5.8, y is equal to comma, no, semicolon, semicolon, y is equal to 3.2. Now
Yes.
what, yes, what we have, now what we have got is, we have got two values, two variables x and y. I want to use x as another variable. So another value. So I want to clear x. What I'll do is, I will write clear x. So write clear x. Okay. Now you can see the workspace X value is clear. If you write clear all will be clear. You write clear, then X, comma Y, comma Z. So X, Y, Z will be clear. Write a clear X, X only X will be clear. Okay. So always when you start writing a program, always clear everything so that your program, whatever value you give, those will be used. If somebody else has used it and those values are stored, then you may get into problem. That is why you should clear all. That is a good practice. Clear all in the beginning, clear all is a good practice for a program. Okay. Now let us go to the students. Any one of you who has written a program, please tell us. We'll write that program and run it. We'll see if there is any error and we'll correct that error. So any one of you can volunteer. Saurav, uh,
Sir. Namaskar, sir.
namaskar. You can write your program. Tell your program. You can tell the line numbers. First line is this. Second line is this. Okay, I will write it out. Your program will write your program and check it in a script file if you have a program.
कोई sir?
Have
Sir,
you
you
written
share your
a
program.
program? MATLAB program we had discussed in the last two classes. I told you that you write a program, then you will learn. So have you written a program? Any one of you who has written a program that will test now, whether it is correct or incorrect, where is the error and what is incorrectness in that will clarify so that you will get clarified. Otherwise, there is no point in taking a MATLAB class if you are not doing it. Anvesa,
Anvasa is not there. Only one person is there. Sumita Patnaik, and
Sumita,
Saurabh Kumar Biswai.
they are only there. Others have left.
Yes, yes.
Okay. And then there is no point continuing. Should we continue or we should not continue? We stop here. I don't know. Okay, I gave one example, first example, solving a linear equation that you can show them. Okay, that example we can show them. Those who are
Sir,
there, they can see that
we'll
example.
go through. Okay, let me show. Suppose you have it is visible to you, sir.
Yes, it is visible to me.
So I want to solve this linear equation having three variables x1, x2, and x3. So to solve a three variable equation, at least we required three equations. So here it is four equation. So we can solve by Gauss elimination, yeah, in any other method. But here we can use simply some simple command to solve these three, yeah, four equations. So at first we have to equate all the coefficient of x1, x2, and x3 to a matrix A. So at first here it is a matrix A and 1. Here just equate the coefficient of x1, x2, x3 of from first equation to the first row. So here it is 1, 1, 5. Look at the equation number 1. Here you will get the coefficient of x1 is 1. Similarly, the coefficient of x2 is 1 and the coefficient of x3 is 5. So put all these coefficients of equation 1 in the first row. Again, equate all the coefficient of second equation in the second row. Here I put semicolon means the second line is second row. Similarly, equate the coefficient of third equation to the third row And again, in similar way, we can equate the coefficient of equation 4 in 4 number row. So when you run this section, look at, so you will get a matrix which contains all the coefficients of all these equations. So
Can
once
you,
you equate,
Akhila, can you expand this? The font size is very small.
okay,
Right. So the first row is for the coefficients of the first equation, second row is for coefficients of second equation. Similarly, fourth row is coefficients of the fourth equation.
okay. So once you run, you will get a what matrix which contain the all the coefficient of all these four equations. So once you get all these coefficients in a single matrix, then the next task is to extract the right hand side values like 6, 8, 10, and 2 to another matrix. So here we will write, suppose it is B. B equal to 6, 8, 10, 2. So just write 6, 8, 10, and 2.
And this is a column matrix. So 6 semicolon 8 semicolon 10 semicolon 2.
Okay. Otherwise, you can transpose
Transpose that.
the
Okay.
matrix by just putting a what
Apostrophe.
apostrophe.
Dash.
So
Dash or apostrophe.
now if I run, you will find B in a column matrix. Once you transpose your B matrix, you will get it in the column form. Now the task is to combine these two matrices to a single matrix. Suppose it is M. M equal to A space B. Now if we
So this
run,
is concatenation or augmentation of A with B. That I told you. Augmentation or
okay,
concatenation of A with B. So A then space B. So it is a concatenation of the column B with matrix A. So if you run
Saurabh,
that, M is equal to this.
Saurabh, you can ask if anything you have. I mean, if you have any doubts, because we want to make this session, but in that two-way process, not like we will do and you just listen it. Once you listen, you may forget, but you have to engage with us. So whether you understand or not, just reply.
I understand.
Okay. If anything if anything you think that it is difficult, then you can suddenly reply with, okay, no
Okay.
problem. Whatever you feel it is little difficult, then no problem, you can reply. So once we make the concatenation of these two matrices, now the task is to reduce by Gauss elimination method, which already told by Sai, like we can write CR equal to RREF. This command is basically used to to reduce the whole matrix,
Row reduction. This is row reduction method.
row reduction method. So now if I run this command, look at, your matrix is reduced to only two rows. So here you will get two rows. Why it is two rows? Because its rank is two. The matrix, whatever in the M, the matrix M is a rank 2 matrix. So here one question is that how you will calculate the rank of this matrix. So to suppose just write a k equal to rank and your matrix. So here it is rank equal to 2. So you will reduce the whole equation into two equation. So what actually it means? So here you can easily identify the coefficient of x1 equal to 1 and coefficient of x2 equal to 0 and coefficient x3 equal to 3 and all total equal to 2. Similarly, in the second equation, it is the coefficient of x1 equal to 0 and x2 equal to 2, x2 equal to 1, x3 equal to 2, and the right hand side it is equal to 4. Look at, you will get a first equation. Is it visible to you? X1 equal to 2 minus 3 x3, x2 equal to 4 minus 2 x3.
x1
Sir,
is
is
equal
it
to 2.
visible?
No, this not visible, but we can
Okay,
understand
okay.
that x1 is equal to 2 minus 3x3. Uh,
No problem. I will text. Sorry.
mm,
Okay, let me copy to an Word file. Now it is visible to everyone.
yes, x1 is equal
Yes.
to 2 minus 3x3, x2 is equal to 4 minus 2x2. Now go back to the
After
equation
reduction,
here.
the whole four equations we will get these two equations. So from these two equations we can
No, no, go back
calculate.
to those four equations. Those four equations. So those four equations. Okay, now you can see the
Okay.
first. Let me tell you. First one is 1, 0, 3, 2. So from that you get x1. x1 is equal to 1. x1 is non-zero. x2 is equal to 0 in the first row. So x1 is equal to 2 minus 3 x2. Second one gives you x2 is equal to 4 minus 2 x3. Okay. So from that you are getting this, the other one. Go back to there. Show them that
Okay.
they have to relate this. See. So 2 minus 3x3, 4 minus 2x3. That is
So
what you are getting.
this was the previous one, and now we reduce this one into this one.
Right. Now you have to solve this. Now you have three unknowns, x1, x2, and x3, but two equations. How you are going to solve that? That is the question.
You
If you
can
know
solve by
first,
taking a value
if
of
you know,
x3.
if
Suppose
you
we put
know,
x3 equal to what?
guess a value for x3, start with that, then you solve it iteratively. Gauss elimination method is that. Ah,
So suppose x3 equal to it is 1. Okay. Then if you put a x3 the value of x3 at equation 1, we will get x1 equal to how much? 2 minus 3 equal to you will get minus 1. Now if I put the value of x3 in the second equation, I will get the value of x2. So x2 equal to how much? 4
ah,
minus 2 equal to 2. So you may have a question like why we get various values like we are not getting a unique solution, why we get a like many solutions. So how you will get a conclusion that whether your equation will give a many solution, yeah, a single solution. So this is a big question. Before you solving your equation, you have to uh, get a conclusion about the solution, whether you will get a single solution, yeah, multiple solution. So the question is that, so how you will find whether it is a unique solution, yeah, multi solution. So to find this, you have to calculate the rank of matrix. Suppose the rank of matrix is equal to the number of variables, then you will get a unique solution. Otherwise, you will get a many solution. So in the previous section, I showed you that the rank of the given matrix is here. Look at the here rank of the given matrix is 2, but actually the equation contains 3 variables, so they are not equal. So that we get many solutions. But again, I will show you one more equation that contains 2 or 3 variables. There you can easily find whether if the rank of the matrix is equal to the number of variables, then how we will get a unique solution. Saurabh,
Again.
are you getting my point?
Yes.
I'm saying you that here, okay, look, here we get many solutions. Suppose you put x3 equal to 1, you will get one solution. And again, if you put x3 equal to 2, you will get another solution. If x3 equal to 3, then another solution. So here you can say we got many solutions. So how you know whether it will give you many solution or a single solution? So to check this point, you have to calculate a rank of matrix. Once the rank of matrix is equal to the number of variable, then you will get a unique solution. Otherwise, you will get a many solution. So here in this example, the rank of the matrix is 2, but actually the number of variable is 3, x1, x2, x3. That's why we get a many solution. Okay, if I will show you another example, then it may clear your all doubts. If there is any doubt. So here another example I want to show you. Suppose I have these 3 equations. Okay, these 3 equations contain x, y, z. Means x, y, z. These are the 3 variables, and I want to get the value of x, y, and z. To get the value of x, y, z, I will go through the same process. Like I first equate the coefficient of x, y, z to a matrix. Okay, so let me follow. Okay, now I will equate all the coefficient to a matrix B. So how I will equate? Just like 3 space, here the coefficient of y is how much? -1. So I will put here -1. And again the coefficient of z is -1. So I will put -1. And again the coefficient of second equation, I will put them in second row. So just by putting the semicolon, we will put all the coefficient of second equation in second row. So the second row contains the coefficient like 1, 1 and 0, because there is no term like z. Here in the second equation, there is no term like z. So the coefficient of z is, we can take it is 0. Again for third equation, we can put like 2. Here in the third equation, you can find there is no term like y. So in the place of y, we can put 0. And for the coefficient of z, we can put -3. Okay, now half of the task is done. So now if I run this program, look at, you will get B matrix contain all the coefficients of all the equations. 3, -1, -1, 1, 1, 0, 2, 0, 3. So from this beginning, you can easily find whether it will give you any solution any solution. So in order to know whether it or many solutions, you have to calculate the rank of the given matrix. To find the rank, then I mark rank B. It will give you 3. It means the rank of the given matrix is equal to the number of variables. It means you will get a unique.
Akira, your voice is
You
stacking.
will
There is net problem. Disconnect and connect once more.
now. Hello.
Hello. Now let us share your
Can you
screen,
read?
please. No, it is not visible. Your screen has not come. Hello. Hello. Akira.